wants to. I want them to be able to look at it. We're going to be looking just at linear functions today, right? And we have been looking at linear equations out the actual wazoo. So we're not learning anything new today, but you guys already know a lot of what we're learning today. You know, if I have an equation in the form y equals mx plus b, what does m represent?
Y, no, the slope.
The slope. M is the slope, and b is the y-intercept. Okay? So we're going to be using that today, but we're going to be looking at these in real life situations. Never have I ever been going through my life and thought, y equals mx plus b, and I'm just going to graph this random line. But I got my degree in physics, and I absolutely had a set of data. And I would look at my set of data, and I would plot my data. And the first question I had for my data was, are you linear or are you nonlinear? And if it's linear, then I would need to find the slope and the y-intercept. But what does the slope really mean? We were talking about rates of change yesterday, right? Do you remember we talked a little bit about rates of change? The slope is how fast things are changing. And what is the y-intercept? What does that y-intercept mean? Not how it changes. Not when it changes. It doesn't have anything to do with any change. So if you're going to use the word change, let's let Kaiden answer.
Where it starts.
It's where it starts. Do you remember when we did our state fair thing, right? The B was what? What was the B on that equation? Not numbers, but what did it mean? You remember? It was the entrance fee to the fair. So you had it was like 50 cents a ticket, right? And the more tickets you bought, the more tickets you spent. But it was 50 cents a ticket, so that was your rate of change. If you bought more tickets, your cost changed at the rate of 50 cents a ticket. If you bought 10 tickets, it was $5 more. If you bought 20 tickets, it was $10 more, right? But it started at, I don't know, like $8 to get into the fair. So your B is where it starts, and then it just goes up or down from there. Okay, so let's look at this. So Zara owns a fashion boutique. She launched a promotion where followers of her social media account who tag a friend are entered into a giveaway. The linear relationship between the hours since launching the promotion and her total number of followers on social media is shown on the graph below. I'm going to be honest with you. When it comes to followers on social media and things like that, that is absolutely something that if you have a reason to have followers, having a graph like that is very, very helpful. You can see, am I going up, am I going down, and am I going up linearly or exponentially? I'm honestly surprised that she's going up linearly. Usually when you have something like followers on a social media account, they'll go up exponentially. So it'll look something like, she'll start with 300, and then that friend tells a friend, and then that tells a friend, tells a friend, and it ends up going like this, and it gets very, very big, very, very fast. When things go viral, they get exponential. I tell two friends, those two friends tell two friends, those two friends tell two friends, those two friends tell two, you know what I'm saying? If everybody tells two friends, you get an exponential graph. That's where you get the x squared, is everybody's telling two friends. If everybody tells three friends, what do you have? X cubed, right? So, but this is linear. Her social media is growing linearly, which is great. I mean, we love that it's growing. We're surprised it's not growing exponentially. Just put on my desk. So find the rate of change. So remember, the rate of change is always going to be over 1. How many per 1? So we've got our units. How many per hour? How many followers is she adding per hour? It is always the y over the x, right? That's our slope, is change in y over change in x. But for her, it's followers per hour. Yeah, Maddie.
It's 1 over 2.
Is it 1 over 2?
It's 100.
It's okay, so it's from 300 to 400 takes how many hours? 2. So it's every 2 hours she's getting 100 more followers. So Maddie, I love that you made that mistake. Thank you so much for going to bat for us. You need to watch your units. These are not ones, they are hundreds. And a lot of the times in graphs, you'll graph things by hundreds. If things are going really, really quickly, you don't want to graph by ones because your graph will be huge and it's not helpful. So every 2 hours she gets 100 more followers. So how many followers does she get in 1 hour? 50. So her rate of change is 50 followers per hour. And she can see if this continues, she can make predictions. How long is it going to take me to get to 1 million followers? That's significant in social media because at certain follower numbers, you can start monetizing. So a lot of people who are YouTubers or influencers or whatever will track their followers so they can know, okay, at what point am I going to start monetizing? Because there's one in particular that I follow. She organizes things, right? Probably you guys wouldn't follow her, but she organizes things. She goes around, she organizes people's houses for them, and she gives organization tips, and she's pretty entertaining about it. Well, she really, really cared because people will hire her. They will pay her money and they say, my house is trash. Come and organize my house for me. And that's her job, right? But creating content on YouTube takes time. And you can't be organizing people's houses at the same time that you're creating content on YouTube. So she kind of had to make a choice. So she took a gamble and she took on less clients so that she could make more YouTube content, right? But now, guess what she's not making from the clients? Money, right? But now she wants to make money on YouTube. So she would do well to graph it and go, how long is it going to take me at this current rate of change? Can rates of change? Yes. Right, but we can use them to predict a little bit. At this current rate of change, how long is it going to take me to start making money at this? So it's actually a really, really valuable tool. And I know that a lot of kids want to be YouTubers and want to be influencers. And so this is a really good real life scenario for this, right? So find the y-intercept. What is the y-intercept on this one? 300. And what does it mean in this situation? Followers when?
Every hour.
No, not for every hour. That's 50 followers an hour. That's our rate of change.
Oh, every.
When she started?
When she started. The morning she woke up and she said, I'm going to have a fancy promotion. That morning, at that moment, she had 300 followers. So she had 300 followers when she started. That is significant because with her promotion now, she's at like 750 right here. How many has she actually picked up through her promotion? 450. So she hasn't really picked up 750 followers through her promotion. She has just picked up 450. Now, granted, I mean, she's more than doubled her followers. That's significant. Her followers have gone up by 150%. That's huge. But she didn't start with nothing and then go to 750. So now we're going to write an equation to represent the situation. And our equation is going to look like y equals mx plus b. Y equals, what is the slope here? What's our rate of change? 50. X plus, where did we start? 300. So we could use this to predict. Now this graph ends at 9 hours. We could use this graph to predict where is she going to be after a day. How many hours are in a day?
24.
24.
You're awake for like
24 hours
hours
in a day.
It's 24 hours in a day. Wow, we have fierce May brain, don't we? Wow. All right. So after, if she goes for a day, if she goes, at this ride, would you mind closing the door? Those kids are noisy out there. If she goes for a full day at this rate, how many followers can she expect to have? So, I mean, this isn't one part of the questions, but it's useful to be able to do. So we would say y equals 50 So 50 plus 24, that's the same as 10 times 12, but that's the same as 100 times 12, which is a lot easier. So that's 1200, right? Y equals 1200 plus 300. So at the end of the day, she can expect to have 1,500 followers.
Oh my.
Right? Oh my. If she keeps going at this rate. Now, like I said, I'm genuinely surprised that her rate is not exponential. Usually when you have something like this, it goes exponential, which is very exciting because exponential things get very big, very fast. You know, you'll have a graph that's more like this. And once it starts doing this thing, woo, it gets big. I have to scroll down to the next one. I'm never gonna do the first 3 together. Oh, hey, so it's doing that. I never know what the whiteboard's gonna do. Is it gonna keep it in place? Is it gonna move it? I don't know. I'm just glad I fixed the whiteboard. It wasn't talking to the computer like 4th period and then this morning, but I fixed it, so we're good. Oh, but look, I can still draw with my finger, but then that's so weird. All right, whatever. But then I didn't understand. I can erase that, but I don't erase that. All right, whatever. Okay, we'll just smile and nod. All right. Sean recently went skydiving for his birthday. That is both awesome and scary. Okay, the relationship between the time in seconds, x, and his elevation in feet, y, is shown on the table below. Okay. So at 0 seconds, he was 12,500 feet. What does that mean in this situation? Started at 12,500 feet. Now he jumps out of this airplane. Woo! Is he gonna go up or down? So is his elevation gonna get bigger or smaller? Smaller. So you need to make sure some of these, you look at these graphs on this assignment today and you're like, what? Like there's one where these kids are going to school and it's their distance, it's a downward slope because their distance to school is getting smaller and smaller and smaller, which is kind of like, duh, is that number 5?
Yeah.
I don't remember. But it's like, but you don't think of it being, you think I have gone this far, so you think the graph would go up. But in that case, it's distance to the school, so of course it's going to get smaller. So make sure when you read these, you're like, all right, what is this graph really showing me? So this table is showing me his distance from the ground, which of course is going to be getting smaller because he's falling, okay? Oh, I'm super curious to know if they actually used real physics on this. We will see. We will see.
Wait, how do you know these?
Because I know the acceleration due to gravity.
Yeah, it's 9.81.
Yeah, but this isn't meters per second. This is feet per second, so it'd be 32. After 1 second. So let's see. Let's see. Actually, this should be, oh, this isn't real physics. In real physics, it would be accelerating. It would not be linear. So the writers of this story probably ignored physics, which
Makes sense.
no, kind of makes me ragey, but whatever. I would not have written this problem because I don't ignore physics when I write problems because, I mean, they need to be real life. In real life, it's exponential because you get faster and faster and faster. But this dude is falling at a constant rate of speed. I'm judging a little bit, but that's okay. Okay, I was going to say I'm not going to judge, but I am. Okay. So Sean went skydiving, and we've got time in seconds and elevation in feet. We're going to assume that this is linear because this assignment is all about linear equations, okay? So find the rate of change and explain its meaning. Now, last time we had a handy graph. Graphs are lovely and wonderful for finding rates of change. Tables are great. I don't think they're as lovely as wonderful because you can't count. But let's look, okay? So what are our units going to be? When we fall, how fast are we falling? Like, tell me, how fast would I fall? Something feet per second, right?
Yeah.
So our units are going to be feet per second. So this is our y, and this is our x. It's feet divided by seconds, right? So in 2 seconds, How far does he fall in 2 seconds?
Wait, no.
We go from 500 to 150.
650. Wait, what? I mean, for adding.
250.
Olivia Fisher, please come to the office. Olivia Fisher.
So 500 minus 250 is 250. So what is it? 350. But are we going bigger or are we going smaller?
Negative 6.
So we're going down 250. 350. Now, remember back in the olden days when we were learning this stuff? y2 minus y1 over x2 minus x1. That's 100% legit what we just did. We just did it a little bit more intuitively. We did 12,150 minus 12,500 divided by 2 minus 0. It's 350 divided by 2. So how many feet is he going per second?
352. What?
What's 350 divided by 2? I have, is it 175? Is it 175? So he is going negative 175 feet per second. What does that negative mean? Means he's going down. Means he's going down. If he was going up, if he was in a rocket and had been launched up, which would be really weird because he's skydiving, but you know, if he was going up, then it'd be positive, but he's going down, so it's going to be negative, which means every second that distance is going to be getting smaller, which makes sense because he's falling, right? So he's going negative 175 feet per second. Find the y-intercept. What's the y-intercept in this thing?
I don't know. 0. Wait, 12.
Okay, the y-intercept is where we start. Where did he start?
12,000.
12,500 feet is where he started. Where is he going to end?
0.
He's going to end at E0. Some graphs go on forever. This graph does not. Unless he like plows through to the center of the earth, right? But he's not. Okay, write an equation. Can we write an equation to represent what's going on?
Yeah.
Okay, y equals, what's his rate of change? Negative 175 x. So x is going to be the number of seconds that he falls. So after he falls 1 second, he's gone 175 feet. After he falls 2 seconds, he's gone 350 feet down, and this negative sign means down, plus 12,500 where he started. See how these work with the real life scenarios? So you can see, okay, how long is it going to take him to get to the end? We're also going to do number 3 because number 3 gets a little more intense. So I figured we could either do it together or I could hold your hand. Or I could like run around and help everybody. So I figured I'd just do it all together. It's easier that way. What? What? I hear a what? Tish. Oh, we've got Tish. Okay, so we've got Bakery A and we've got Bakery B. Tish is ordering custom cookies for an upcoming soccer team celebration. And she's comparing the costs of 2 local bakeries. If you order things and you do not compare the costs between your vendors, you are done. Tish is a smart young lady. She's like, I'm going to get these cookies. They're going to be expensive. I want to do this the cheapest that I can, okay?
What if you want good cookies?
Okay, so you do have to compare, but we are assuming that Bakery A and Bakery B have comparable quality. Now, if Bakery A is significantly better than Bakery B, but they also cost a little bit more, you have to decide, do I want to pay a little bit more for better cookies? And that's where you start making those decisions. If I am buying cookies for a kindergarten birthday party, do they need to be super high quality?
No.
Actually, really not, right? So I can get the cheap cookies. If I'm buying cookies to the governor's going to be in Blackfoot on May 30th. If I was going to buy cookies for that whole reception thing,
Yes.
would I buy the cheapy ones?
No.
Probably worth the expensive ones, right? So this is where you make those decisions. But we are pretending for this scenario, Bakery A and Bakery B are pretty much on par. They both have really good cookies. They both have flavors that we want. We just want the cheaper ones. This is all we want in our lives, okay? So, this is what kids are saying. Okay, so we're gonna have the cost per cookie, and then we have a delivery fee. Does the delivery fee change with numbers of cookies?
No.
It does not. You buy 100 cookies, it's a delivery fee. You buy 5 cookies, it's the same delivery fee. So the delivery fee does not change. Some places, you hit a certain amount, you have no delivery fee. Not these guys. They just have their delivery fee, okay? By the way, having free shipping after a certain amount, if you guys ever open a business, it is brilliant. There have been so many times where I've been like, I can spend $12 on shipping, or I can buy $20 more worth of stuff and then get free shipping. And guess what I do?
You get the more stuff.
I get the more stuff because I want something for free, like for my money, right? I'm really only spending it $8 extra. So brilliant, brilliant business market. Okay, so Bakery B, Bakery A, what is their delivery fee? And how can we tell?
$7.
Bakery A.
$5.
How did you tell it's $5, Shaylee?
The graph starts at.
Because the graph said, if I order 0 cookies, it's $5. So that's my delivery fee. Now, I don't know why they're delivering 0 cookies to me. That'd be really weird. Hey, can I just have you come over and pay me a visit? Like, that'd be weird. But that's our delivery fee. So Bakery A is a $5 delivery fee. What's Bakery B's delivery fee? $7. Bakery B has a delivery fee of $7. So right off the bat, Bakery B is more spendy on their delivery fee. I have no idea why they have chosen a higher delivery fee, but they have, okay? So, which bakery charges a higher price per cookie?
Bakery B.
Well, do you know that?
No, I guess.
We don't know that. I don't know that. Because we can't just look at that and go, oh, for 2 cookies it's $11.50, and for 2 cookies it's $10, because the delivery fee is included in that right now. If I was only buying 2 cookies, it'd be cheaper to go with Bakery A. I don't have 2 cookies delivered. That's dumb. But we can't just compare the cost. We need to look at the rate of change, okay? So to go from 0 cookies to 2 cookies, how much does the price go up? So we have $4.50. Really, this is $4.50 for 2 cookies for Bakery B. Okay. You know what I'm gonna do? I'm gonna do Bakery A in green so that we can tell the difference between them. So A is $5. Okay, so Bakery B is gonna be blue. What's $4.50 divided by 2?
$2.25.
$2.25. So Bakery B is $2.25 per cookie. So Bakery A, if I go from 0 cookies to 2 cookies, it goes from $5 to $10. So what's the change? $5 change. So we have $5 for 2 cookies. So how much is 1 cookie for Bakery A? What's 5 divided by 2?
2.5.
So Bakery A's cookies are $2.50. Oh, dun dun dun! Do you guys see it? Bakery A has a cheaper delivery charge, but they charge more per cookie. And Bakery B has a more expensive delivery charge, but they charge less per cookie. So if Tish orders a dozen cookies, which bakery is the cheaper option? And is it Bakery B
No.
or is it Bakery A? Neither one of these graphs goes all the way to 12. So you know what we're going to have to do? We're going to need to write ourselves an equation and math it. So B's equation. B's equation, the total cost, we're going to call the total cost Y equals, how much is it per cookie? 2.25 times X, which is the number of cookies, plus, what's our delivery charge?
7.
7. So Y equals 2.25. How many cookies are in a dozen? 12. I'm glad you guys knew that. So what does that equal? What's 225 times 12?
That was 25 plus 7.
It's not 25.
27.
So 2 times 12 is 24.
It's
And then 0.25 times 12 is 3. So it'd be 27 plus 7. So we're talking $34 for 12 cookies. Okay? Let's look at A. So our total cost is the cost per cookie, which is $12.50 or $2.50 times the number of cookies plus our delivery charge, which is 5. It's a less of a delivery charge. So Y is $2.50 times 12 plus 5 was $2.50
30.
times 12. Is it 30? What's 30
35.
plus 5?
35.
So for 12 cookies, it's going to cost me $35. So pretty much, if I get less than 12 cookies, Bakery A is going to be cheaper. And at 12 cookies, Bakery A is more expensive. So if you're going to buy like 10 cookies, probably Bakery A is going to be cheaper. If you're going to buy 20 cookies, go with Bakery B. We're only $1 different here. So if we're only $1 different, this one might be where it comes down to, okay, is Bakery A slightly better quality or is Bakery B slightly better quality, but they're the exact same quality and we're just looking at numbers and numbers. Or if you don't care if your soccer team gets the best cookies, I'd go with Bakery A because they're cheaper. No, go with Bakery B. Bakery B is cheaper. Oh, sorry. Okay, I think I'm gonna let the rest of you go on your own.
Do number 4. Yeah.
I'm not gonna do number 4. I'm gonna let you wrestle with it a little bit. But you're gonna look at the rate of change. What is the rate of change in a linear equation? It's the slope. And the y-intercept, that B, is just wherever we started. Sometimes we start with money in the bank. Sometimes we start with a delivery fee or whatever. A lot of the times we start with something. All right, everybody have any questions? We're all feeling good.